Greetings, math fans. All right, so today is day 2 of chapter 1 for calculus. And again, it's a little bit of review here, but then we're going to get into some new stuff. We're going to talk today about composite functions and logs. Okay, so those of you who know this is one of Logie's favorite topics. All right, so let's start with composite functions. All right, so composite functions, basically really fast outputs are used as inputs. Get my grammar here right. So outputs are used as inputs to another function. There we go. All right, so you guys, I'm sure you remember it, right? F of g of x, that's how you say it, f of g of x. You might have remembered it also as f in that little circle there, g of x, right? Some of you might have learned it as fog or goff or whatever, but those are identical. Okay, so let's do a real basic one here. So there's 3 kinds of problems. The first one's like super easy. If I give you f of x is 2x plus 3 and g of x is x minus 7. Okay, and I can ask you some questions about it. I can say, what is f of g of x? Okay, so basically what you're doing is you're taking the g of x and you're plugging it into f of x. So you're taking this x minus 7 and you're putting it into that x right there. Okay, so let's do that. So f of g of x is, like if I put that in, it's 2 times x minus 7 plus 3, because you put the x minus 7 in where the x is. And then, guys, you need to simplify it. If you leave it like this, I'm going to take a point off. Okay, so 2x minus 14 plus 3, so that gives you 2x minus 11. So that's f of g of x. All right, and we can do g of f of x, right? So that means you just take the f of x and you put it into g of x. So I'm going to take that 2x plus 3 and put it into the x here, and then it's minus 7, right? So that gives us 2x minus 4. Okay, pretty easy. Let me just cursor down here a little bit. You can also do f of x, right? No big deal. So that means we're just going to put a 2x plus 3 in where the x is. So it's 2 times and then 2x plus 3, and then plus 3. Don't forget that, right? Okay, so we simplify that. It gives us 4x plus 6 plus 3, or 4x plus 9. Okay, and let's do this one. F of g of 2x. Okay, remember I can write it either way. This is fog of 2x. So basically what you're doing, it's kind of like saying, I kind of like to write it with the parentheses, f of g of 2x. I kind of like this notation better because it kind of shows me, hey, I'm putting a 2x in for the x for g of x. So let's do that. So that's going to be, let's do g of 2x first, right? G of 2x is going to be, put a 2x in there where x is, so 2x and then minus 7. So that's what g of 2x is. And then you just take that and you put that into f of x. So f of 2x minus 7 is just going to be 2 parentheses 2x minus 7 and then plus 3. So that gives you 4x minus 14 plus 3, or 4x minus 11. Okay? So that's pretty easy, right? That's something you guys probably have learned already. So that's pretty mellow. Okay, so let's go on to the next type of problem. So now what's going to happen is you're going to be given So this is problem number 2. And you're going to be given f of x and f of g of x. And let's just give that to you right now. F of g of x is 6x minus 2, and I'm going to ask you to find g of x. So I'm going to put in parentheses, this is actually the easy type of problem, it really is. So the question you're going to ask for this kind of problem is, what do you need? What do you need to plug into x for f of x to get 6x minus 2, right? I need to plug something into f of x to give me 6x minus 2. So that's pretty easy. It's basically you're saying, well, here I need to give you f of x. Oh yeah, okay. So just to get this one. So here, let me give you f of x. That's helpful. 2x minus 6. Okay, so f of x is 2x minus 6, and f of g of x is 6x minus 2. Okay, what do you need to plug in to x for f of x? So I need to plug something into here to give me 6x minus 2. Okay, but that's my g of x that I'm plugging into there. So watch, it's easy. So it's 2 times g of x, right? Because that's what I'm plugging into it. So 2 times g of x minus 6 is going to give me 6x minus 2. And basically what I'm doing is just doing algebra now, and I'm solving for g of x. It's pretty easy. So I'm going to add 6 to both sides. So 2 times g of x equals 6x plus 4, and then divide by 2. So g of x is equal to 3x plus 2. That's it. Pretty easy. And guys, it's like super easy to check this just to make sure you're doing it right. Okay. So I'm telling you f of g of x is 6x minus 2. So let's actually find that, right? If I take the 3x plus 2 and I plug it into 2x minus 6, so 2 times 3x plus 2 minus 6, I better get 6x minus 2. So I get 6x plus 4 minus 6, or 6x minus 2, and I do. Same thing. Okay, so super easy check. And again, this is the easy one. The harder one is actually finding f of x, and that's going to be our last one. Okay. All right, so let's do that. G of x, so this is our third category here. So g of x is equal to x minus 4, and f of g of x is equal to 2x plus 6. And my question is, what is f of x? So I'm going to put in parentheses, not as easy. Still not bad, okay? Still not bad. All right, so basically what we need to do is we need to plug in g of x into some equation to get 2x plus 6. So we have to find out, what do I need to plug that x minus 4 into to give me 2x plus 6? I got to plug it into something, okay? So basically, this is what I have. I have f of x minus 4, right? That's like f of g of x, right? This needs a little parenthesis here. Okay, so I need to, this is my g of x right here, g of x. I need to plug this into something to give me 2x plus 6. So what we're going to do is we're going to start with the variable first. Start with variable. And do you guys agree I need to really, in order to get to be a 2x, I need to multiply the whole thing by 2. So 2 times that x minus 4 gives me 2x minus 8. So now we're actually pretty good initially because I have my 2x. Okay, but I don't have plus 6. That would have been really nice, right, if I got plus 6 right away. But I have minus 8. So really what I need to do is think about it. What do I need to do to get the, right, this needs to be that number right there. It needs to be a plus 6. So what do I have to do to that? Well, again, I multiply the whole thing by 2, and then I got minus 8. And then how do I get that to be plus 6? Well, do you guys agree that I really need to add 14 to that? Everybody agree with that? If you add 14 to that 2x minus 4, you get 2x minus 8 plus 14, which then gives you, it gives you the whole thing, 2x plus 6. Okay? So if I would actually write this out now, f of x, I need to multiply it by 2. So I need to multiply that g of x by 2 and add 14. And that's my answer, math fans. Okay? And again, so here's just a real quick recap here, right? So I started with the variable. I'm like, okay, now how do I get that x to be a 2x? Well, I have to multiply the whole thing by 2. So that gives me the 2 times x minus 4, which gives me 2x minus 8. And then I'm like, oh, and then I needed to get to plus 6. So I'm at minus 8 right now, so I have to add 14 to that. And that's how I get the 2x plus 14. And again, it's like super easy to check this. Okay, so again, if I do f of g of x, just to check it, right, I'm going to take the g of x, which is x minus 4, and I'm going to plug it into there. So 2 times x minus 4 plus 14. That should give me 2x plus 6. So you get 2x minus 8 plus 14, which of course is 2x plus 6. So that checks out. Okay, so let's do one more example with this one, because I think this is the most difficult of all. So let me give you g of x is 2x minus 5, and f of g of x is equal to negative 6x plus 3. So remember, you're taking this, you're taking that 2x minus 5, and you're plugging it into something. So I'm saying, well, f of that 2x minus 5 has got to somehow give me negative 6x plus 3. All right? So again, do the variable first. Well, how do I get that 2x to be a negative 6x? I have to multiply it by negative 3. You guys agree? So if I do negative 3 times that 2x minus 5, I get negative 6x plus 15. Now that's great. So I have my variable part here, but I need to get it to plus 3. So what do I do to go from 15 to plus 3? I have to subtract 12. So that's the other part. Okay, so here that's that part and that part. So I have to multiply the thing by negative 3. So basically f of x, I have to multiply it by negative 3 and subtract 12. Okay, so that's your answer. Not bad. Okay, so again, let's do a little quick check here. So f of g of x, I take the g of x again, which is 2x minus 5. So negative 3, 2x minus 5, and then minus 12. And that should give me negative 6x plus 3. So negative 6x plus 15 minus 12. Hey, look at that. Isn't that cool? Plus 3. Yeah, baby. Okay, same thing. How you doing? All right, cool. So that was pretty easy. That's composite functions. All right, so now let's do logs. Again, log E's favorite topic. You're all very familiar with log E. Okay, so logs, of course, being the word logarithm. Logs are actually kind of cool. I don't want to take up too much time here because you guys are, listening to my video here. But logs are cool, right? If I think of like a really good application of logs is the Richter scale, right, for an earthquake. I think it's just kind of cool. If you talk about like a 5.0 versus a 6.0 earthquake, people think, yeah, okay, it's a little bit more powerful, but actually it's a logarithmic scale. So 5.0 to a 6.0 is actually 10 times more powerful. And a 6 to a 7 is another 10 times more powerful. So to go from a 5 to a 7 earthquake magnitude is 100 times more powerful. And I was just kind of looking online, I think in Chile, In South America, the most powerful earthquake was like a nine point something. So that's incredible. I mean, a 6 is a devastating earthquake. 7 is actually really brutal. Just destroys, knocks buildings down. And go from a 7 to a 9 is 100 times more powerful, which is just brutal. So not to be a downer, but I'm sure there's other friendlier applications of logs. Okay, so let's just talk about some properties. You have log of xy. So that's multiplication. And remember, you can expand that. And this is, when I write it this way, now I'm going to expand it. Okay, and that's going to be log of x minus log, sorry, plus log of y, right? So multiplication is addition between these two. So of course, log of x over y, it's the xy, ooh, scary, is log of x minus log of y. Basically, oh, there's loggy. Look at that, loggy, that's cool. So basically, it's top minus the bottom, okay? And then the last one that's really important is log of x to the y power. And if you remember, you take that y and you put it in front. So it's y log of x. Okay? So that's it. Now, I want to kind of warn you here, math fans. This is like a common mistake. So I'm going to write, don't do this, which is just common. People kind of get confused and they do this. They say log of x plus y. And they say, oh, that's log of xy. And that is not correct, okay? You actually, so I'm going to put a not equal to sign here. You actually can't do anything. If it's log of x plus y, there's no expanding it. You can't do anything with it. It's log of x times y is log of x plus log of y. But if you have log of x plus y, please do not write it as multiplication. I mean, you can even see. Certainly this is not the same as this, right? Okay, so don't do that. Same thing with this. If I said log of x minus y, I get kids who have said, oh, well, Mr. Kerfus, that's log of x over y. And I say, boo. Okay, don't do that. Very bad. So not equal to. Very, very bad. Okay? All right, cool. So just be careful. Don't, if you see log of x plus y or log of x minus y, cannot simplify. Only log of x times y, log of x over y, or log of x to the y power. That's what you can simplify. Okay? All right. So let's do a couple problems where we expand now with, hopefully you have those in your notes already here. So the directions will say expand. Now there are two ways to expand. One is just eat a lot of food and then you'll expand, guaranteed. Okay, and the other is using these directions here. But it'll say expand completely. So basically, when I say expand completely, this is what I mean. No exponents or multiplication or division. Okay, that's what expand completely means. Okay, so here's the first one here. If I said log base 2, and remember there's no base in there, it's automatically base 10. If it was ln, it's base e. Unless it's very specific, you would have like, this is log base 2. So log base 2 of 3x to the 5th. Okay, so that's pretty easy. The first thing I'm going to do is I'm going to kind of break it up with the multiplication. So it's log base 2 of 3 plus log base 2 of x to the 5th. That's cool. So that breaks that up because it's just multiplication. And then, again, no exponents. So really my final answer is log base 2 of 3 plus, I'm going to bring the 5 in front. 5 log base 2 of x. And there we go. That is expanded completely. Okay, so let's try another one here. Same directions. Log of the cube root of xy to the 4th. So the first thing that I would do, math fans, is I would rewrite that cube root just so it makes, you see an exponent. So log of xy to the 4th to the 1/3 power. I would do that. Because then I could see I use my exponent property and you basically just get 1/3 log of xy to the fourth. Okay? And now, once we took care of that, now I'll look at multiplication here and just make sure it's really a parenthesis around here, so don't forget that. So it's log of x plus log of y to the fourth. And I'm going to actually just go quickly here in that it's the 4, I'm going to move it in front. So 4 log of y. And that's my final answer. Okay? Right? No exponents, no multiplication. When I say multiplication, of course, it's 1/3 times that. But when I say no multiplication, it's like x, y to the fourth. That's multiplications. You can't have any of that left over. Okay? All right, let's do, I got a couple more to do with you guys. Just a little crazier, but it's okay. Same directions, expand completely. Log of 2x to the 8th over 3y to the 6th. So that gives you, I'm going to do division first. So it's log of 2x to the 8th minus log of 3y to the 6th. Okay, so there's multiplication here now because let me really put that in parentheses. That's probably good. Okay, so I'm going to break that up to log of 2 plus, and it's log of x to the 8th, but let's go a little faster here. So 8 log of x and minus, so let's again use a nice little parenthesis here because you're just subtracting both of them. So it's log of 3 plus 6 log of y. Okay. And you can distribute that. It's okay. And that's it. Okay. So it's completely expanded. Okay, last one. Last one. So log of 2x squared plus 3y to the 10th. Okay, so do you guys agree I can do log of 2x squared plus log, I'm going to put that in parentheses, log of 3y to the 10th, right? We can expand that out. Everybody okay with that? Boo! You can't do that. Okay, again, you guys should recognize that that's not a property of the logs where it's log of a plus log of b or log of x plus log of y. You can't have that. You can't simplify this problem. Okay, it is log of 2x squared plus 3y to the 10th, and that's it. Okay, that's why I put a big red X. Big red X means wrong. So I'll just put boo. Can't simplify. Okay? All right, cool. So I've got a couple more problems here, guys, because we're going to actually use our properties to solve problems with logs. Okay, so let's do that. Okay, so solve using logs. And so basically what I'm going to do is I'm going to say solve for y. So you got 2 to the y equals x. Okay, so kind of nice. We take the log of both sides. Now you could use ln. It doesn't really matter. Natural log or log base 2 or 8 or it doesn't matter. Okay, let's take the log of both sides. It's fine. Log base 10. Okay, so by using then what logs enable you to do, they enable you to basically move the exponent out from its position into the front, which it is. We're using our nice little exponent property of logs. Moves that y in front. Instead of y, log 2 equals log of x. Sweet. So we're done. It's just multiplication. So log of 2. So that's my answer. Y is equal to log of x over log of 2. Okay, that's your answer. And again, if you use natural log, that's okay. Of course, who prefers to use natural log is our good friend Loggy, because he's a natural log. Okay, enough with Loggy jokes, sorry. All right, so let's do another kind of crazier looking one. X plus 4 is equal to 3 over 3 minus 2 to the 5y. Woo! That's a humdinger. Humdinger. Okay. It is kind of a brutal problem, but it's really not that bad. Okay. What we need to do is we need to isolate basically the 2 to the 5y. Because once we do that, then we just take the log of both sides, and then we're good to go. Okay? So what I'm going to do is I'm just going to cross multiply. So let's put a 1 underneath there. If I do that, I get x plus 4 times 3 minus 2 to the 5y is equal to 3, and then divide both sides by x plus 4. So 3 minus 2 to the 5y is equal to 3 over x plus 4. Subtract 3. So negative 2 to the 5y is equal to 3 over x plus 4 minus 3. And I'm going to just divide everything by negative 1, right? Because I don't want to get rid of the negative. So now I have 2 to the 5y is equal to 3. I'll just move the 3 in front now because that's positive. So 3 minus 3 over x plus 4. Okay? And then, we'll do natural log this time. So we're going to do ln of that, and that's in parentheses, ln of that. So I can move that 5y in front. So 5y ln of 2 equals ln of 3 minus 3 over x plus 4. And again, please, math fans, you can't distribute that natural log and say natural log of 3 minus, it's like that, or do any division. You can't simplify that. Okay. So my very last step here is I'm going to divide by. I need to get rid of the 5 in the natural log too, so I'll just do the one step. So 5 ln of 2. 5 ln of 2. And that's it. So it looks ugly, but that's what it is. So it's y is equal to ln of 3 minus 3 over x plus 4 over 5 ln of 2. Woo! See why I wrote humdinger? It's not bad. It's like you're just using a little bit of logs, and then everything else is algebra. So algebra is easy. Okay. All right. So I got one more problem here to solve with you guys, and then we'll be done. Okay. So let's. Okay. So to solve, now this is the other one was solve using logs, and this is actually solve a log problem. So basically what this has logs in it. Okay, so if I start out with ln of y plus 3 plus ln natural log of 4x equals ln of 2x plus 9x. Okay, so again, what we're going to do, I'm solving for y. Okay, so we're solving for y, right? Okay, so the first part is pretty easy. I just need to kind of move stuff over. So I'm going to basically isolate the y term. So if I do that, I'm just going to subtract natural log of 4x from both sides. So I get ln of y plus 3 equals ln of 2x minus ln of 4x plus 9x. Okay, nice and clean. And basically, and the way to get rid of a natural log is you raise everything to the e. Raise every side to the e. So e to the blah. So what we're going to do is, it's just like saying, if you do e to the ln of something, e to the ln of something cancels it out. So it cancels. So e to the ln of, let's say, 8 equals 8. So that's kind of nice. So I'm going to do e to the ln of y plus 3 equals e, and that's kind of a large thing. You can't, oh, by the way, this is like a really bad thing to do. You can't say e to the ln of 2x minus e to the ln of 4x. It's e to the whole thing on top. So it's ln of 2x minus ln of 4x plus 9x. It's all raised to that power. And you're like, ooh, that's kind of messy. It's going to get a little bit friendlier as we move on here. So let me move this down a little bit. First of all, that just cancels it out. So I get y plus 3. Sweet. Right? That's pretty good. Now, here's the deal, math fans. I can simplify things a little bit. Basically, do you guys agree that the if I have e to the ln of 2x, let me actually write this out. If I said 2 to the 10th power minus 4, do you guys agree that's 2 to the 10th over 2 to the 4th? Right? And then I could say 2 to the 10 plus 4, the same thing as 2 to the 10th times 2 to the 4th, right? Because what do you do when you multiply with same bases? You add the exponents. So these go together, okay? And these go together. So if I subtract, I divide. So 2 to the 10th divided by 2 to the 4th, the same thing as 2 to the 10 minus 4. Okay, so that's going to kind of help us, because otherwise this right side is like super nasty. See, it's a minus here. So I can say it's e to the ln of 2x. This is addition, so I can't do anything with that. Actually, let me get rid of that little plus sign here, because sorry. E to the natural log of 2x times e to the 9x over e to the 4x. And okay, so let's look at it for a second, right? You guys agree? Because e to the ln of 2 plus e to the 9x. So that's like this guy right here. The addition is just multiplication. Same base, right? So it's e to the ln of 2x and e to the 9x, and that's multiplication. And then it's minus 4x, minus natural log of 4x. So that part, it's divided by, right? Okay, so you got to get that. This is algebra 2. You actually remember that. This is just your properties of exponents. Okay, and so we're almost done here, math fans. Because now e to the natural log of 2x is just 2x. E to the 9x, well, you can't do anything with that because it's e to the 9x. It doesn't have a natural log. Oh, and I lost something here. Sorry. Gah. It should not be 4x. It should be ln of 4x. Maybe you guys noticed that. Okay. So, and then it's divided by e to the natural log of 4x, so it's just divided by 4x. Okay? Right? E to the natural log of something is just that something. And that's why it's simplified. E to the 9x, I couldn't do anything. So we are almost done. I can cancel the x's, and then 2 over 4 is 1/2. So it's e to the 9x over 2. My last step is subtract 3 from both sides. So my final answer is y is equal to e to the 9x over 2 minus 3. Woo! That was a humdinger problem too. Okay, I definitely kind of made this one a little more aggressive because what I don't want to do is give you a bunch of easy problems and then I give you like a homework problem and you're just like, wow, I have no idea how to do this. So I gave you something kind of tough. We worked through it and we're good to go. So that's it, math fans. Composite functions and logs. Okay, using logs to solve problems and solving log problems. All right, that's it, math fans. Hope you enjoyed it. I know Loggy did, and you have an outstanding day. Adios, math fans. Goodbye.